Okay, I want to start over, so I don't want to confuse you from the beginning. Okay, so I have this one first. Let's start over for the first one, right? Step one, you have to input this data. You want to find a mean and a standard deviation. You have to put this one in a table. Where to put it in a table in here is go to stat, edit, and then input all the data, which I already input in everything in L1, right? And then you go to stat again using cal, using the one variable statistic, okay? And the default is on L1, which is right. So we hit enter. Now you have a X bar, which is the bin, okay? 910 X bar is the bin in here. This one, you want to find a sample standard deviation. So sample XX is the sample standard deviation. Sigma X is the population standard deviation. Since this one is telling you is a sample, so you're going to using XX 305.3. All right. And C here, which is the critical part, very important. Do I use the G interval or do I use the T interval, right? Similar in the chapter 7. So 6 and 7 have something in common here is G and T. The credential is the same. Okay, so if you do the chapter 6 well, you can do the chapter 7 well, because they follow the same credential. The way you find the G interval, okay, the way you find a G interval is when sigma is known, population standard deviation is known. The way you use the T interval is when sigma is unknown. In chapter 7, is using the G hypothesis test, okay? And then the T hypothesis test follow the same condition as here. So do we know the sigma in this one? The answer is no. We didn't give you as the population standard deviation. This one is just sample 12 for high school senior, okay, on the state test score. So the population standard deviation is not given in here. So this is just 12 sample. So that will letting us that we have to use the T interval instead of the G interval, okay? And let me show you the quick and easy first using the calculator. Okay, let's go to the easy one first using the calculator because yeah, a lot of time this interval you can use the calculator, which is really quick and easy. So some people say everything, if we have everything using this one would be fantastic, right? So how do I use the interval? Go to stat test, okay? We are not using the G and T test yet. That's in chapter 7 hypothesis test. We are using the interval. So you have to scroll all the way down to look at the interval in here. Okay? Interval. G interval or T interval in here. All right. And don't use anything with start with 2 because in this elementary statistic, we have a, if we have a proportion G test, that will be only just using 1. Okay, so that's the later one. All right, so we're going to using the T interval in here. That's how you identify the G or T interval. Okay. When I put a T interval in here, I can go to the state, which I have to input my X bar or XX, right? Or I can using the data. Look at it. If I didn't calculate earlier, why this one pop up? Because I using my day earlier. If I don't calculate the one step earlier, I can just go to the data using the data. Say go to the L1. Yes, I'm using my data from L1, okay, to calculate this one. And how much is my interval, my percentage? I want you can change this one into 95% or 99% or 98% easily from here. If I have a 98%, I just change it into 98%, right? Since this one is 95%, so I'm gonna go ahead and use the 95 and just hit enter. And that's your interval. Really quick and easy. That's your final answer. Look at that. How easy is that, right? That's your interval. So it's 716, it's wrong to 1 decimal point. So 716.0, okay? And then that's 1114.0. If you want a 1 decimal point, you just give it 1 decimal point. okay? And that's it. That's your 95% confidence interval. So using calculator super fast, all right? And I'm sure some of the later on we can use the formula as well. But this is how you use the calculator, okay? And then if you want to using the state test, if you want to using the G interval, that's your G interval, but you have to choose the correct one, okay? So that's why I said earlier, using G or T, the decision is very important, right? Because the calculator won't tell you which one to use. So you have to using the credential we have in this case. Okay, let's look at the second one. Test the crime about a population being at a level of the significant assumed population is normally distributed. As I mentioned earlier, this is not in the order, okay? But if I want to go through the order here, let's go ahead, since we are doing the review. I want to go ahead and review the 6.2 first and 6.1, okay? So 6.2, and then we're gonna come back to the chapter 7, probably a little bit easier that way for our review. Find a critical value T sub C for the confidence interval. C is 0.98 and the sample standard deviation is 13. So T sub C, you want to run to the nearest thousands. That means 3 decimal point. Okay, so you need to read this table in here. And one thing is so where do you find the table? Let me show you this table in here. This is a G table, right? And then you also have a one called T distribution table, which is table 5, okay? So if you look at the table 5 here, your left-hand side is using the DF, which is the degree of the freedom, okay? And the DF here is using the DF. DF is using n-1. Degree of the freedom is using n-1. All right. So we have an n here is 13. N here is 13. So 13 minus 1. 13 minus 1 is 12. So we have DF is 12. Okay. So we're going to go to look at, and then the C here is 0.98. Okay. All right. So 12 right here, right? And then, so we have a 12, and then the C here is 0.98, so that's 0.98, so right here. All right, so this one will be 2.681, okay, 2.681, you just copy it to here. That's how you read the table. All right, so let's go ahead, finish the 6.2, chapter 6 first, and then we're gonna come back to chapter 7. Okay. All right. So that's chapter 6. We're going to go through the interval. Okay. In a random sample of 21 people, the mean value to work, the mean commute time to work is 34.6 minutes. Standard deviation is 7.1, right? Assume population is normally distributed and using the T distribution. Okay, this one is better. Even telling you want to using the T distribution. To construct, that means T interval. Okay, construct 80% confidence interval for the population mean, and what is the margin of error of the mean? Okay, so margin of error. All right, so how do we do this one in here? Confidence interval. Okay, as I mentioned earlier, since this one you want to find the T distribution, so I can go to using the T interval in here. T interval. Oh. Okay, so where do you find this one? Go to state test, and then you find a T interval. Okay, and then we hit enter. Now this time we don't have a data, so we're gonna using the state. Okay, and then we enter the X bar, so we change the X bar here is 34.6, and the standard deviation is 7.1. Okay, and N here is 21, right? And the confidence interval here is 80%, which we have to convert it into decimal point. 0.8. And then we just go ahead, hit calculate. Okay, so we got this confidence interval. All right, it run to 1 decimal point, so this will be 32.5. The other one will be 36.7. Okay, so that is your confidence interval in here. All right. Okay, so sometimes people say, now how do I find my margin of the error in here? Okay, so find the margin, or if you know the confidence interval, you want to find a margin of error, actually is really easy. You can use the bin. Remember, I said it earlier, we have x bar minus mu. Oh, I'm sorry. X bar minus E, right? And then this is X bar plus E. All right, so if you want to find a margin of error in here, I want to find the E. I can using one of the X bar, okay, using the mu, okay, take an absolute value. If I using the 34, which is my bin, and then minus this one, minus 31, 35. Okay, so I can using the one of them, take an absolute value, okay? I'm using 34.6 minus my left-hand side, 32.5, okay? If you're using 36.7, that will also work, minus the 34.5. This is giving you the same answer. Well, because the rounding, so it's a little bit different. This is giving you the 2.1. This is probably giving you the 2.2, right? Because the rounding error in here. All right. So, but it will give you very similar answer. Okay. The 2.1, 2.2 should be both are correct. In this case. All right. So that's the margin of error in here. Okay, so that is, and then let's go ahead and look at what is on the 6.1 in here. Okay, so that's why I want to, giving you all the chapter 6 first before we move on to the 7. Okay, so you giving the sample bin and the population. Look at it. This one is telling you the population standard deviation. Use the information to account 90% and 95% confidence interval for the bin. Okay, so you random sample 40 home theater system has a bin price. This one is telling you the population standard deviation. That means this one is sigma, okay, equal to 17.5. So this one will be a G interval. Okay, G interval. Why is it G? Because it's giving you the population standard deviation. The whole thing, that is the key thing. Population standard deviation. All right, that's the key. So we need to using the G interval because, as I mentioned earlier, sigma is known, is given. And which one is the sigma? Sigma is the population standard deviation. So this is a G interval, okay? And I can also find this one using the 90%, 95%, using the calculator, super easy, super fast. Okay. All right, so I go to stat, test, and remember, we want to using the G interval because the population standard deviation is given. All right, so make sure we enter. And then we don't have a raw data, so we're gonna using the state in here. So that means we know the sigma, we know the X bar, right? Sigma telling you here is 17.5. Okay, X bar here is 134. Okay, and then the N here is 40. Okay, so the first one we want to calculate is 90% confidence. So we change this one into 0.9. And then we calculate, we got this interval already. It said 1 to 2 decimal point. Okay, so 2 decimal point in here, we have a 129.45. That's, and then to 138.55. So that's the two interval in here, two decimal point. And then we're gonna come back here to do the same thing again. Okay, we're gonna go to the G interval again. Okay, this time we just, everything else is the same. We just have to change this interval into 0.95. Okay, and then we hit calculate, and this is our new interval, 128.58 to 139.47. And basically you want to compare what's different of these two intervals. Okay, so if you have a 90 5%, so this is interval is 95%, right? Interval 95%, so you have a 128.58 to 139.42. So you have this one right here, which is much bigger. And then this is, and then we have a C equal to 90% confident. Okay, so let's see what is our 90% confident. We have a 90% confident earlier is 129 something. Okay, and then this is 138, which is right here, 138. All right, so what does that mean in here? That means if you confident, if your interval getting smaller, right? This interval is smaller. Your confident is also smaller. If my interval is really big, I have a higher confidence. Okay, so let me give you one of these example for this one. If I ask you, how many of you think your test 4 gonna be between 90 to 95, for example? How many of you say your test 4 gonna be between your test 4, okay, your unit 4 test gonna be between 90 to 95? Okay, how confident you are? And some people say, yeah, I have a 90%. All right. How about if I enlarge this one? Okay, if okay, I'm gonna have a set. You have at least 70, and then between 70 to 98, right? I increase this interval. Oh, some people say I have a probably 95% confidence, right? Yeah, because this interval is bigger. Now I have a more confidence that I'm gonna hit at least this range, because this range is much bigger than this range. Okay, so that is something like that. That is the confidence interval and the confidence label. Okay, so that's the kind of giving you a quick example for that. Okay, so that is pretty much chapter 6. Okay, find the margin of error of this one. Okay, so this one is finding the margin of error using C, X, and N. So we need to go to see which formula to use. So you have to use this one right here. This one you have a E, X, and N, which is for the T interval. Okay, for the T interval in here. Okay, the C confidence label margin of error in here. So how do you find this one? E is equal to T sub C X over square root of N, right? Let's see. T sub C X over square root of N. Okay, so that's the formula you're gonna use, right? And we have X is equal to 4, N is equal to 6. The only thing we do not know is T sub C. So we have to go to read the table for T sub C in order to calculate this one, right? And we said earlier, T sub C, you have to using degree of the freedom, which is n minus 1. So 6 minus 1 will be 5. Okay. And then C here is 0.8. And then we're going to go to read the T sub C. All right. So let's go to read the T sub C. C here is 0.8, right? And then DF is 5. So it's 1.476. Okay. That's for the T table. All right. Remember, the T table is always, okay, let's look at this one. This is always using DF, okay, degree of the freedom. So make sure you remember minus 1, using n minus 1. So my T sub C here is 1.476. So my E here will be 1.476 times X is 4, square root of n is 6. And then we just calculate this whole thing. So this actually is multiply the numerator, right? Multiply the numerator and then divide by this one. Okay, you can go to put in a calculator and find the answer on your own. That should be easy that way. All right, so that's how you find the margin of L, okay, for this chapter 6. Okay, another chapter 6 here. This actually, you want to find a minimum sample size n, okay, giving you everything in here. How do you find the n? So we have a formula to find the n here. This is your n formula. This is your n formula, okay? One thing is when you find the n, you have to always round up. Okay, so n formula. The n here is G sub C times sigma over E, and don't forget you have to square them. Okay, all right, so I think I'm not going to do the detailed calculation. I'll just show you how to do that, okay? Because those detailed calculations take a little bit longer time. All right, so how do you find the G sub C? You will have to go to using C is 98%, okay? And sigma is already given to you. Sigma is 5.5. E here is 2, right? So the key thing here is you have to go to find the G sub C. What's confident interval? Confident interval is always in the middle. Okay, confident interval C is always in the middle in here. So if you want to find a G sub C, usually you take the positive one, right? So because when you square them, it will still positive anyhow. So if you want to find the area to the depth, this will be 0.01, right? And then this side is also 0.01. So how do you find this one? You're using 1 minus this one divided by 2. 1 minus this one divided by 2. You got this one, you got this one. All right, so it's 0.01. So if you using a calculator, you're gonna have to go to area to the depth will be 0.01. Or if you have a nice calculator, you can find the area in the middle is 0.98. Let me show you the calculator. So this is back to our chapter 5, finding the inverse norm. So you go to the second distribution using the inverse norm right here, right? And then if you have a 0.98 in here, and I said, oh, okay, this is my center area. Okay, I can use this one. And I passed, and I'm giving you the 2G score. One is positive, one is negative. We always using the positive one to do the calculation. Okay, so it's 2.33, round to 2 decimal point. So your G sub C here is 2.33, okay? And then now you can do the calculation. So I have my, okay, I'll just do one calculation in here. Okay, so I have a 2.33 times times what? 5.5 divided by 2. All right, and I forgot the square, so I have to square them. Okay, and like I said earlier, this is always round up. Okay, So it doesn't matter how small or how big, you always have to round up for the sample size, because otherwise you won't have enough sample size. So for even this one is less than 5, you still need to round up. So this is called spatial rounding for the sample size. For 8, 4181, okay? Unless you got an exact answer. I don't have an exact answer. For the sample size, if you don't have an exact answer, always round up. Okay, so that is your n in here. Okay, so that's called a minimum sample size. Okay, let's go ahead, look at chapter 7, okay? Let's look at some chapter 7 in here. Let's start at 7.1. Yeah, 7.1 is a good start, okay? A known and alternative hypothesis are given. Do you know this is a left tail or right tail? What kind of test? So left tail or right tail, you always look at the alternative one, okay? Alternative one, this is a known hypothesis. Known hypothesis always include an equal sign, okay? And the alternative one is a complementary for the non-hypothesis. So you can see chapter 7 got a little bit more concept, okay? So my alternative one, alpha is greater than 2.3. So what does greater than mean? Greater than mean is area to the right, okay? So that's the right tail test, right tail test. So this should be a right tail test in here, okay? If it's left tail test, should be less than, all right? So look at this one. Give you the statement to represent a crime. What is the complementary to the known and alternative hypothesis? All right, so this one is include an equal sign, right? So number 5, you have an include an equal sign in here. The known hypothesis always include an equal sign. So this is H sub 0. Okay, and your alternative one is a complementary for this one. So this should be less than 608. So that's less than in here, should be less than. Okay, and you can go to match the correct answer for this one and this one. All right. Okay, that's 7.1, right? Let's look at the 7.2 in here. P-value for indicate hypothesis, which is giving the standard test G, determine do you reject the label of the significant in here or not. Okay, so one thing is if you're using the p-value, okay, this is something you want to remember. If p is less than or equal to alpha, you reject the non-hypothesis, in here. And what does reject the non-hypothesis? That means non-hypothesis always assumes something is equal, right? And the alternative one said, no, that's not equal. So, or depends on what your non-hypothesis is, okay? So if you have a p is less than or equal to alpha, you reject. If p is greater than alpha, you do not reject or fail to reject. Fail to reject. That's a concept for this 7.2, right? So we already given you alpha is 0.05. And then how much is the p-value? Well, this is a right tail test. So what is right tail test? That means the area to the right. Okay, and my z-score is 1.83. So I'm going to find my this area. What is the area to the right in here? So if I go to read this z-score, I will be able to know the area to the left, right? 1.83. So let's go ahead and read this one very quick. 1.83. 1.83. This is a z-score. 1.8 right here. 1.83 will be right here, 0.9664. 0.9664, right? And then this area to the right will be 1 minus 0.9664. Okay. Is it 0.64 or 9? Um, 1.8 is 64, not 69. 64. Okay, so we subtract from here, so that's 0.0336. All right, so my p-value is 0.0336. My alpha value is 0.05, right? So I line up with this decimal point. So you can see my p is less than alpha. P is less than alpha, right? So you line up the decimal point. So you know the P is less than alpha. So P is less than alpha, that means reject non-hypothesis. Okay, that's something you do have to remember on your one page C in here. So you reject a non-hypothesis, that one. Okay. All right. This one is for the statement below, write a crime as a mathematical statement, state a known and alternative hypothesis, okay, and then trying to see which one represent the crime. So this one is a laptop manufacturer claims that the being life of the battery for a certain model is more than 6 hours. Okay, so what does more than mean? More is greater than 6 hours. Okay, since this greater than 6 hours did not have an equal sign, so let's go into the alternative hypothesis. So we know the alternative one. We know the alternative one. Mu is less than 6. And what is my norm? My norm should be complementary in this one. So my norm should be greater than or equal to 6. Okay. And since this is the question that the question tell us, so this is the statement or the claim from the question. All right. So using these three, you can go to choose the right answer, right? Mu should be what is the claim of the math statement? The claim here should be mu is less than 6. So should be this one. Mu is less than 6, right? And what is the correct known and alternative hypothesis? Or the known should be greater than or equal to 6. So that should be this one, right? Greater than or equal to 6. And then this one will be less than 6. Oh, I'm sorry. I take it back. I probably got it up. Sorry about it. I got that wrong. Okay, more than is greater than. All right, take it back. Take it back. Erase that. Going too fast. All right, more than. Okay, this one is more than. So more than should be greater than. So this should be greater than. All right, and where's this one? So the norm should be complementary, less than or equal to. Okay, this one telling you the life is more than is greater than 6 hours. So this should be the alternative one. And this is still the crime, right? And if non is complementary, so the non should be less than or equal to 6. Okay, so let's take it back. What is the statement? Statement here is more than 6 hours. So more than 6 hours should be greater than. Okay, so should be B, greater than. All right. Sorry about it. Take it back. Okay, more than, greater than. All right. And what is the norm? What is the correct one? So mu is greater than 6, right? So go to choose mu is greater than 6. So this should be F. F in here. F. Mu is less than or equal to 6. F is the correct one. And then E is the correct one in here. Oh, I'm sorry. Take it back. B is the correct one. More than 6 hours. Greater than. All right. And then this is mu is greater than 6. And non is less than or equal to 6. So this is the correct one. Okay. And which one is the claim? Well, this is the claim. More than 6 hours is the claim, right? So the claim should be go to find something is, this is the claim is the statement from the question. So go to find something is greater than 6. Okay. So the alternative one, mu is greater than 6 is the claim. Yeah, that's one. This one right here. Okay. Yeah, so you have to be very careful. As I mentioned earlier, when I go too fast, I make mistake as well, right? So always read the question. I said read it at least 2 or 3 times because that's how easy you can make mistake. Okay. All right, let's look at a little bit calculation in here. Okay, how do I calculate this one? A light bulb manufacturer guarantee the mean life is ADs. What does ADs mean? Okay, so that's another key word in here. ADs. ADs, that means greater than or equal to. ADs, greater than or equal to. Okay. Sample random of the 21 light bulb, the mean life is 720. Assume this whole thing is normally distributed. And look at it, this telling you population standard deviation. So that means it's sigma. That means it's a G interval. Okay, that is the key thing. Alpha equal to 0.05 to have enough evidence to reject the claim. So step one, you have to identify the known and alternative hypothesis. So how do I write this one right here? This light bulb is at least 73, so this includes the equal sign. So that means this is the known hypothesis because I have an equal sign. Known is always have an equal sign. So we want to go to choose someone that has a greater than or equal. So just like this one, right? If something is greater than or equal to. So that's the only one in here. And this is the claim because this is a statement from the question. So that is the correct one. Okay. And then your alternative one will be the complementary for this one. So should be less than. Okay. How do I find the critical value for G? I can, using the formula, I can also using the calculator. If I use the formula, let me show you which one to use. Okay. So, chapter 7, G, this is the formula you can use. Okay, x bar minus mu, similar as the chapter 5, we calculate the G value. All right, but if you don't want to calculate this one by hand, you can also do that in a calculator. Let me show you a calculator, but at least you know which formula to use. Okay, so I am going to use my calculator. It will show you the G interval, a G score. All right, this is a hypothesis test, right? And as I mentioned earlier, we know the population standard deviation. So this one will be G test. Okay, this is not an interval, but a hypothesis test. So we're gonna use the G test, and then we hit enter. And then we have to input this statement in here. How much is my mu, which is my mean here, right? My mean here should be light bulb, the mean life. Okay, so my mean here should be 733. Sigma here is 65. X bar here is this light bulb has a 720 hours. N here is 21. Okay, and this one is important because you're gonna have a left tail, left tail, or right tail test. Okay, and then you look at the crime here, look at the alternative one. Our alternative one here is less than, so this should be a left tail test. Okay, so we're gonna go to the left tail test. Left tail or right tail, you look at the alternative one. Look at the alternative one. Okay, and then we hit enter. Oh, that way we have a G score right here. So we have this is a G score. Okay, and then this G score is round to how many decimal point? Round to 2 decimal point. So the G score here will be negative 0.92. Okay, negative 0.92 in here. And this is a left tail test. Okay. All right, so choose the correct one. It's a left tail test, so this should be the correct one, right? This is area to the left. So left tail test in here. Okay. And the good news is if you use the calculator, it's giving you the p-value. This is the p-value that we can compare to the alpha. So p here is 0.1797. Okay, this is our p-value. All right. Okay, so if we using let's see how much is our alpha in here. Alpha is 0.05. Okay, so that's a good thing with using the calculator, giving you automatically giving you the p-value. P apparently is greater than alpha, right? This alpha is 0.05. My P is 0.17 something. So definitely greater than alpha. So greater than alpha, you fail to reject, fail to reject, fail to reject the non-hypothesis. Okay. So you fail to reject the non-hypothesis. That means there's not enough sufficient to reject the crime that the mean value of the life is at least 377 hours. And if you do not know how to choose the final answer, let me show you one of the things on the module here. Okay, if you go to the module, this is the page. You can actually print it out for your test if you want. Okay, so key formula table. I think it's not in the module, maybe under the announcement somewhere. I think I'm trying to put in a module in here. Okay, so if you go to the course material here, I'll show you. Go to this link, you can access all the review in here. Okay, let me show you which one you can print it out. It's a table that you can know how to make a conclusion. Okay, I think I probably not posted in here, but I will post after the class, okay, since that's for the next week. But let me show you which one I was talking about. Okay, so hypothesis test for outcome. All right, this is the page I was talking about, especially for the beginner if you do not know how to make a conclusion. Okay, so using this table, all right, using this table in here, determine where you learn and where you cram. Okay, if you learn, if you cram is in a, if you cram is in a learn, you reject the non-hypothesis. That means there's not enough evidence to reject the cram. If you do not reject or fail to reject the non, that means there's not enough evidence to reject the cram. So this is the page. It's 4 different outcomes. Okay, 4 different outcomes. That's the one. This is a page you can use to determine which conclusion you're gonna have. All right. So I'll post this page on the link. Put it in the module in here. Okay. So if you do not know how to make a conclusion, go to refer to this page of the table. That's what I'm trying to say in here. Okay. All right. Using the p-value is without performing any calculation. Okay, match the p-value with the graph, display the area without performing calculation. Explaining in reason p equal to 0.171867 and p equal to this one. Okay. All right. So what does the p mean in here? This one, z is negative 0.29. This one, z is negative 0.89, right? This G value is much less, so this P should be smaller. Okay, this area is bigger. So so the first one right here, the first one, this one should be corresponding to this one, right? Because this one is much smaller. This one looks like area is bigger, so that should be this one. So this one should be for this one right here. Okay, this area. Okay, so that is this one, and you can go to match the answer. Okay. Okay, this one is using the t distribution, and then you have a c x bar. You can use this calculator to find the interval really easily. Okay, so let me just go ahead, go into how do you find the interval using the t distribution. Go to stat, test. Remember, this one is the interval, not a test. Okay, because you look at this one, is using the assume funder indicate confident intervals. So you have to go to the interval in here. And then this is telling you it's t distribution, so it's t interval, right? And then the x bar here is 13.2, x is 4, n here is 7, confident label here is 0.899, and then just hit calculate, and that's it. You run to one decimal point, read the description carefully, right? You want to just run to one decimal point. So this will be 7.6, 18.8. Okay, that's it. All right, so another this one, another interval in here. Okay, so this one in a random sample of a cell phone, the bin retail was 500.5, standard deviation is 2 to 3. Assume population is always normal distributed using the t distribution. I like that they tell you the t distribution. Okay. Um, and then construct 90% confident interval for the bin, right? Identify the margin of error. Okay, so how do you find the margin of error? You can go to find a confident interval, and I'll show you how to find the margin of error. Or if you want to do this one earlier, you can use the formula to find the margin of error. Okay, so margin of error for T is using this formula, Okay, if you're using this formula, you have to go to read the critical value as I mentioned earlier. Okay, because T sub C, giving you the X, giving the N, T sub C, you will have to use 90% confident, right? And then the DF is N minus 1. So how much is the N? Okay, all right. So let's see, how do you construct 90% confident label in here? Okay, so we can go to the similar again, stat, test, and then using the t interval, right? And then we are using this one right here. Okay, so this one is tricky. You have to using this is n. N here is a. I couldn't find the n earlier. Okay, that's why you have to read the question very carefully. All right. This didn't telling you the number, but it tell you in a statement in here. Random sample of the A. All right, so your DF will be 7, right? So that's, and then you go to using the confident 90%. If you want to read the table, right? So DF is 7. DF is 7 right here. And then your confident is 90%. So that's your T sub C. Okay, that's how you read the T sub C, and then you input into this formula, you can calculate the margin of error. All right, so that's using the formula. And if I using a calculator, I can do that as well. So if I using a calculator, there's no formula to calculate just the margin of error from the formula. So I will have to calculate my interval first. Okay, so my interval retail price um, standard deviation. We end here is 8. Confidence level, we want a 90%. All right, we can go ahead and calculate. So that is my round to just 1 decimal point, right? So that's 351.1, and then 649.9. You have to round up, right? So that is your interval. And then, as I mentioned earlier, if I use this one, I can calculate my margin of error really quick. I just have to take the absolute value using 500, which is the mean price minus one of them in here, right? And then take the absolute value. So that is my margin of error. Okay, I can use it like say 500.5 minus like I say 649.9. Okay, I take the absolute value. So 649.9. All right. So that will be 149.4 that way. Okay. So that's the quick and easy. If you don't want to use the formula, that's another way you can find the margin of error this way, very quick. All right. Okay, let's look at this one right here. This is two-tailed test. Okay, find a critical value and for the z-test. So remember, this one is using the z-test. It's already telling you in here. Two-tailed test. What is the critical value for the z when the alpha is 0.05? Okay, let's see how do we calculate this one. Okay, we're almost done. Okay, two-tailed test. What does two-tailed test mean? Two-tailed test, that means one is on the left, one is on the right. And then this alpha had to split into two. So two-tailed test. So this is using alpha over 2, 0.02, because alpha is 0.04, right? Divided by 2. So that this is a half of the alpha. This is a half of the alpha in here. So that's two-tailed test. Okay. And so what's the rejection value? So we're gonna go to find a z-score in here. This is alpha. Alpha is the area, okay? So how do I find my z-score? This z-score will be negative. This z-score will be positive. So your z-score have to be less than this one. So less, and then this one on the right side have to be greater than. So this is called a rejection region, right? The critical region is a rejection region. So you just basically find the two z-score in here. So how do you find the z-score? You can use the calculator very quick using the inverse norm. Okay, and the area is 0.02. I have this area is to the left. I'm gonna using to the left in here. Okay, and then I'm gonna calculate. So when I have this is negative 2.05. My right-hand side, since the area is the same, this will be positive 2.05. So when you have an area is the same, absolute value of the z-score is the same. Okay, so your rejection region G will be less than negative 0.5 or okay, or G is greater than and or either side will be good, right? If you fall in this side or this side, they are all good. Okay, so you have a one is less than negative 2.05. Another one is greater than this on the right side should be greater than 2.05. Okay, so that's your two-tail. And which one is the correct answer? This one is the correct answer. That's the tail, right? Not in the middle one, but the tail. Okay. All right. So that is last one. Let's see. This is 6.1 in here. Okay, I think that we talked 6.1 earlier. All right, so that is pretty much it. Okay, I'm going to give you this table. I'm going to give you this page that post on the Canvas, so you can have this one for the test. For the last unit test you have. Okay. All right, so that we'll go through all the Unit 4 review. We will not have a class next Saturday because that is the last day. It's cutting too close, for the day. So I'm going to post this video, so hopefully you will be able to review before the next Saturday. Okay.